Okay, so in question 15, right, we want to find the equation of the curve. We are given the second derivative. So, given the second derivative, we can find out what is the first derivative, which is dy over dx, by integrating your 1 minus x squared. And that will give you x minus x cubed over 3 plus c. Right? Then it says that the equation of the tangent at 1, 4 is y equals to 5 minus x. This means that if you're given a curve at a particular point 1, 4, okay, if I draw a tangent, this tangent is a straight line with the equation y equals to 5 minus x. Which means that at x equals to 1, the gradient dy over dx of this tangent is negative 1. Okay, because from the equation of the straight line, I can tell that the gradient of the tangent is negative 1. So we apply this, okay, into this part over here, which says that the gradient dy over dx equals to negative 1 when x is equals to 1. So this is 2/3 plus c. And c equals to negative 1 and 2/3. Okay, so therefore, at this stage, we see that dy over dx is x minus x cubed over 3 minus 1 and 2 over 3. Okay? Then we want to find the equation of the curve, so we integrate your dy over dx. Okay, and we get x squared over 2 minus x power 4, okay, dividing by 4, then minus 5 over 3x plus d. Okay, so this curve will have this point 1, 4 that satisfies the curve. So that means when y equals to 4, x equals to 1. Alright, so we will do that substitution.
Bro, it's a watch, Joshua. This is perfect. This is perfect for me.
Okay, then we can find out what is the value of d. Alright, so after finding the value of d, we will then find the equation. So I leave the remaining steps to yourself, okay? Then question 17. So, coordinates of the stationary point. So stationary point, we need dy over dx to be equals to 0. So this means that given the second derivative, okay, we can find out what is the first derivative by integrating your 6x plus 3. So we get 3x squared plus 3x plus c. Okay. We need to determine what is the constant by making use of this information, whereby at this particular point, your gradient is negative 18. So dy over dx equals to negative 18 when x is equals to 2. Okay, then we can find out what is the value, what is the dy over dx. So let me continue writing here. At 2 negative 60. Plus 6 C plus 3x minus 78. Okay, we want to find the coordinates of the stationary points. So at this stage, you can let dy over dx equals to 0 already. Okay, so that we are solving this quadratic equation. It will be easier to factorize when you simplify, when you factorize out to 3 or to divide across by 3. Six divided by what? 26. How do I factorize this? Can someone give me an answer? 26, 13, and 2. No other factors, right? Did I get this correct?
Roger, it's not 78, it's 36.
36 ah?
C equals...
Oh! Sorry, this one is wrong. Negative 18. My bad, thank you. Negative 36. So 12. X minus 4 plus 4x minus 3. Okay, so upon factorization, we get x plus 4 and x minus 3, which means that the stationary points are found at x equals to 4 as well as x equals to 3. Okay, but because we want to find the coordinates, that means that I need the y coordinate itself, and that can only be done so by integrating my dy over dx. Okay, so your y is equals to this, and then we make use of the fact that 2 negative 60 lies on the curve in order to find out the value of d. Could someone tell me what is the value of d?
Negative 2.
What do we get? Negative 2. Okay. So therefore y equals to x cubed plus 3 over 2x squared minus 6, 36x minus 2. Okay, so upon getting your y equation already, then at x equals to 4, you can find out what is the value of y. Okay, and then after that, find out what is your second derivative value. Okay, then after that, this will be more than 0. Hence, we can conclude that 4, and I don't know what is this, is minimum.
This part.
Yep.
4 is a negative.
4 is a what?
Negative.
Oh. Sorry, my bad. I have to figure this out. And this one is less than 0, right? So maximum. Okay, then after do the same thing for x equals to 3. Okay, so I will not continue the steps I'm saying. Right? Okay, so that's all. Then can you please submit your homework exercise 16.1 and 16.2. Staple them together if it's not. How do I find the value? Yeah, because you need the y coordinate. Because the question asks for the coordinates of the stationary point. So you need the x and the y. At this stage, you found the x.
You're trying to cheat the day, is
Okay, let's finish up our integration today.
Oh, sorry. You just say sorry to the camera.
He doesn't accept your apology.
Okay, let's take a look at question 11 of your exercise 16.3.
How you doing?
Okay, so I want us to look at question 11, part I. In this question, right, okay, you're given this function y equals fx. In fact, you're not quite given it. Okay, what you're given is the derivative, okay, which is e to the power of negative 3x plus 3e to the power of x. In other words, your f prime x is equals to e to the power of negative 3x plus 3e to the power of x. Okay, in part I, you are asked to explain why the curve has no stationary points.
I keep my leg
We
forward.
know that there can only be stationary points. Is there an concern? What's
I move my foot.
okay? So, we know that there will be stationary points when your derivative can be equals to 0. Okay, so very likely whenever you want to explain this, okay, what I think most of you would do is to by brute force make it equals to 0. Okay, and try to see if there will be x values or not. Okay, but in this case, because the question asks you to explain why there are no stationary points, the expectation that you will have is that there will be no value of x. Okay, but I want to show another way of doing, okay, which is not by brute force, okay, it's by our understanding of our exponential functions. Okay, so when x is when for any real value of x, okay, this question did not give any value of x. Okay, so continue up here. For all real values of x, instead, in case you still don't understand this statement basically means that any numbers itself, okay, any value of x, we know that e to the power of negative 3x will surely be more than 0. Because this is an exponential function, you need to know that exponential functions are positive. Okay? Likewise, your e to the power of x is more than 0, which implies that 3e to the power of x will be more than 0. Somewhat similar to what we had in our WA2, okay? Observing that our derivative is made up of two parts, e to the power of negative 3x, which is positive, and the other part is also positive, having to add two things that are positive will definitely result in a positive function itself. Okay? So we can conclude that your derivative is always more than 0. Okay, and because it is always more than 0, it can never be equals to 0. And because it can never be equals to 0, which explains why, okay, that there are no stationary points. Okay. Let me try to work out the alternative. Okay, an alternative that most of you would likely do, okay, which is slightly longer, is to by brute force say that because that in order to have stationary points, your f1x must be equals to 0. Okay, and then you let the derivative equals to 0, which leads you to actually try to solve an exponential function. Okay, so when trying to solve the exponential function, you see that e to the power negative 3x can be re-expressed as 1 over e to the power 3x, and then you multiply across by e to the power 3x, which results in this. Okay, on the right hand side, 0 times anything becomes 0. Okay, then after that, e to the power of x times e to the power 3x is the addition of your two powers. That's why it becomes a 4x. And then we get 3e to the power of 4x equals to negative 1. Hence, e to the power of 4x equals to negative 1/3. Some of you who are fast enough may realize at this stage that there are no solutions already. Okay, so at different stages you can have that realization. One of which is here, because you realize that exponential will always be more than 0. So the fact that this is negative, definitely there are no solutions. So you may actually end over here already by stating no solution. Okay, then there might be a group of you who still don't realize there are no solutions. You proceed to do your logarithms, okay, and you get ln negative 1/3 equals to 4x. Then maybe some of you know that for logarithm, this number cannot be negative, and then you decide to end here to say no solution. Also okay. Otherwise, you divide by 4 and see that no solution. So at these three places over here, you can actually end depending on your level of realization. Okay. Then, because there are no solutions, you find that hence there are no stationary points. Okay, because it is not solvable. Alright? Okay, so this is really through brute force, okay? Whereas over here is really through understanding of your function itself. Okay, I want us to learn both, right? So that we are prepared, okay, in maybe different ways of phrasing the question. We may ask for different things.
are the properties of God that make certain animals fly? What are the ones that make them fly? What does it
Okay, can I erase the first method already? Erase up. Alright, in part 2 we want to find an expression for fx. Okay, so that means we need to integrate this derivative, and given the information that the curve passes through this 0, 3. Okay, so we integrate in order to get fx. Okay, so integrating your exponential, you get back the exponential itself, not forgetting to divide by the coefficient of x. And for 3e to the power of x, okay, this 3 can be ignored when it comes to integrating. So we know that integrating our e to the power of x remains the same, but our 3 remains. Okay, there's no coefficient of x, so nothing to divide. And then we get our plus c. Okay, so because the curve passes through 0, 3, your fx is equals to 3 when our x is equals to 0. So again, I want to emphasize that e to the power of 0 is 1. Okay, don't make the mistake to think that it is equals to 0, because people very often think that this is 0, 0 and then you get the wrong value of c. Okay, when in fact it is 1 over negative 3 plus 3 plus c. So your c equals to 1/3. And therefore, fx is equals to negative 1/3 e to the power negative 3x plus 3e to the power x plus 1/3. Chapter 16.3 is done. So homework. Okay, for exercise 16.3, would like to give questions 6, 7, 8C and 10. Okay, so homework is due on when can homework be due on? Wednesday? Calm yourself lah. I am aware that it's EPL day. Wednesday can?